So today we're looking at inverse functions, inverse. So when I say the word inverse, what does that mean? Inverse. Yeah, switched, opposite, changed, right? Inverse just means I went out through the door, I go back in through, if I will go in through the door, I go back out through the door. If I take 2 steps forward, I take 2 steps back. It's just undoing the steps, right? For Christmas, you wrap up gifts. Christmas Day, you destroy the gifts, right? You open them up. That's inverse. You're just doing the opposite steps, right? That's all inverses are. So if we add 2, subtracting 2 would be the inverse. If we divide by 2, the inverse would be multiply by 2. Just doing the opposite steps, right? Okay, so what is inverse is besides that, is switching x and y. X becomes y, y becomes x. When we do that, what happens? Create something called an inverse, okay? So this little guy here, when you see that, that means inverse. That means inverse, okay? It's a little notation. It's a little notation for meaning inverse, okay? If you see f of x, that doesn't mean inverse. And f of x just means y, okay? Okay, so easiest type of way to find an inverse is just to switch x and y. So instead of x coming first, y would come first. X would come second. So example 1, if I wanted to find inverse for this function here, instead of -4, 5, instead of going left 4, up 5, I would have to go right 5, down 4. -2, 0. Instead of left 2, up 0, it's going to be left 0, down 2. 0, 4 becomes 4, 0. 6, 1, or 1, 6 becomes 6, 1. And 3, -7 becomes -7, 3. That's it. That's the inverse. So this is the original. This is the inverse. Okay? That's what you do with the dots. You just switch spots. Switch places with the dots. Okay? It's kind of the same way you do a graph, because a graph is just a bunch of dots on a picture. It's a picture of the dots, right? So to graph, what do we got to do? First thing you got to do is make a table. Make a table for the original. Okay? That's the first thing we're going to do. If we're looking at a graph, we got to make a table for the original. So to do that, we need points. I want whole number points, right? Like if I go left 3, up 2, there's a dot right there. I'm not going to go left 2 because then I go up 1.5, 1.6. I don't know what it is exactly. But if I go left 3, I got up 2. That's going to be a dot. Another dot would be at 0, 1. And another dot would be at 3, 0. So let's see, -3, 2, 0, 1, 3, 0. Those are all the dots that I just made. They're all on the same. It's a line. To get from one dot to the next, they should have the same slope. So to get from one dot, I go down 1 over 3. I should have the same distance, down 1 over 3 to get to the next one, because it's slope. That's what slope is. If it's a line, all lines have some slope. Inverse. So the first thing is make a table. Done. Next thing, switch x and y's. So instead of -3, 2, it's going to be 2, -3. So the inverse of the first dot is going to go right 2, down 3. Next one, 0, 1 becomes 1, 0. 3, 0 becomes 0, 3. And it makes a line, a brand new line. Okay, that's the inverse. The red and the black are inverses of each other. They're opposites. How do you know you did it right? Well, if you graphed it correctly, the red and the black should reflect. They should be reflections of each other across a diagonal line. I had that line there. See how the red dot there, this one is left 2, up 1. This one is down 2, over 1. They're the same distance away from each other. Those dots, red and they correspond with each other. -3, 2, so up here. 2, -3 is down here. They're the same distance away from that mirror line. It's called a mirror line. That's true with all inverses. So that mirror line here. So this dot right here goes with that dot there. They're the same distance away from the green. Same thing with this dot and that dot. Same thing with this dot and this dot. They're the same distance away from the green. They mirror. Okay? That's how you know you did it right. Okay. So that's for graphs. That's how to find the inverse of a graph or points. The other thing we're going to do is equations. We'll do that later. How to find inverse of equations. Okay? Let's put phones away. You don't want to make me angry before a test. If I have to ask about phones, ooh, that test is going to be double hard next week. Huh? Yeah, sure, yeah. Okay. Yeah, number 1, make a table for the original. If there is no table, make one. Step 2, switch the values. Step 3, graph it. What does it look like? Make the dots. Okay? Yep. Yeah, probably be a good idea, because if I ask you to do that on a test, it'd probably be a good idea to have that. Yeah. Yeah, so generally, if it's on mine, put it on yours. Unless I say, don't write this down. Yeah, that's just a good idea to follow, because it could be on a test. Okay. Okay. So let's look at the back. So the first thing is, the original is the relation. Create the inverse. So instead of 3, 4, it's going to be 4, 3. Instead of 1, -2, it's going to be -2, 1. Instead of -5, -1, it's going to be -1, -5. Same thing with the rest. They give you a bunch of points. To get the inverse, just switch the points. If they're the same point, when you switch them, like -2, -2, doesn't matter if you switch them because they're just going to stay -2, -2. Same thing, 0, 0. It'll stay 0, 0. Tables are just points. So if the original is -2, -3, I'm going to switch them. -3, -2. The original is -1, 0. The inverse is going to be 0, -1. 3, 2. -8, 7. 9, 9. Oops. You're just switching spots. X's become Y's, Y's become X's. Okay. Middle example. Middle example, graphs, just like we did in the front. Original. Okay, so let's see. Looks like there's a dot there. Looks like there's a dot there. Looks like there's a dot there. So let's see, -2, 1, 2, 3, 4, -2, -4. -1, -1, 0, 2. Those are those 3 dots that I made. I need one more dot though. Well, to get another dot, I'm going to use slope. To get from one dot to the next, I went up 3 over 1. It's got a slope of 3. So to get to the next dot, I'm going to do the exact same thing. 1, 2, 3, up 1. So the next dot, even though you can't really see it because there's an arrow there, would be this guy here. Because they have a slope of 3. So that dot would be 1, 1, 2, 3, 4, 5. Inverse, switch. Graph. -4, -2. -1, -1. So those kind of overlap. -1, -1 is going to overlap blue and red. 2, 0. 5, 1. Make a line. The inverse was, if the original was a line, straight line, the inverse should be the same. Green is reflection line. So these 2 dots are in the same spot on the different sides of the green line. They reflect. These 2 dots are the same. They're the same spots on different sides of the green line. This dot here is in the same spot because it's on the green line. And then last, those 2. Okay. All right. All right, so next one, same thing. Make dots. This one I need 5 dots. So I need more dots. Well, it looks like I go left 2, up 4. Left 1, up 1. 0, 0. 1, 1. There we go. I want whole numbers. I don't want any fractions. So that's why I picked those dots. Because the first dot, left 2, up 4. -2, 4. And then -1, 1. 0, 0. 1, 1. 2, 4. Those are all the dots. Step 2, switch. 4, negative 2. So right 4, down 2, right there. 1, negative 1. Right 1, down 1. 0, 0 is going to stay. 1, 1 is going to stay. 4, 2. Okay. So it looks like the parabola, looks like it just turned 90 degrees, but it also reflected. Okay. So that's how we do it if we have a graph or if we have points. Just switch them, right? Okay, so the last thing we're going to do is what if they don't give me a graph? What if they don't give me points? How do I find the inverse? Those directions are the ones we have on the board. They're the ones we have here on the bottom of the first page. It's the ones on the board. Okay, so here we go. First guy. Okay. First guy, replace f of x. So if you have f of x, replace it with y. So no more f of x. It's going to be y. That's the first step. Second step, switch x and y. So no more x's. So instead of a y equals, it's going to be x equals. And instead of 2x, it's going to be 2y. Everything else stays. The 2 in the front, the equal sign, the +3, everything else stays. All I'm switching is the x and the y's. Okay? Next step, solve for y. So in other words, get y by itself. Right now, it's 2y plus 3. I don't want it to say 2y plus 3. I want it to say y equals. So how do I get that to say y equals? What's the first step I'm going to do? Subtract 3. Good. Subtract 3 from both sides, right? 3's cancel out. So I get 2y. It's 1x minus 3, but I can't subtract them because one has an x and one doesn't. So what do I write down? I just write down x minus 3. Almost there. How do I get y by itself? Divide by 2. So you're going to divide everything by 2. Well, over here, I have 2 terms. It's a binomial, right? I have an x and I have a negative 3. So I'm going to divide both of them by 2. So I have x divided by 2 minus 3 divided by 2. Okay. Last step, replace y with the inverse tag. So instead of y, I'm going to flip them too. I'm going to give it this guy here. That means I'm done. This is the inverse. And what is it going to be? It's going to be x divided by 2 minus 3 over 2. Okay, I'm going to highlight the original and my answer, the inverse. I'm going to look at what we notice. What operations did the original have? 2x plus 3. What two operations does that have? Addition, multiplication, right? So what's the opposite of addition? We have subtraction. What's the opposite of times 2? Divide by 2. When we have divide by 2, that's a way to check your answer. If the original had multiplication times 2 and plus 3, the original had that, the answer should have divided by 2 and subtract. Okay? All right. Okay, so let's go to the next guy. First thing, f of x becomes y. First step. Switch x and y. Everywhere you see an x, change it to a y. Everywhere you see a y, change it to the x. Everything else stays the same. So this guy is still going to be squared, but it's just y squared instead of x squared. How do I get y by itself? What's the first step to get y by itself? Add 4 both sides. Yep. X plus 4 equals y squared. So I almost have y by itself, but it's got a little squared. What's the opposite or inverse of squared? Yeah, square root, right? 5 squared is 25, right? So how do I get from 25 back to 5? Take the square root, right? It's kind of a circle. How do I get it back? Take the square root. So we're going to take the square root of both sides. I have y squared, right? How many answers should I have? 2. So where are both of my answers going to come from? This is where. I'm going to have one positive version of the answer, and I'm going to have one negative version of the answer. Plus or minus. Last thing, switch y out with the inverse tag. You're done. You're just slowly undoing it, like on Christmas Day. You slowly undo the wrapping. Right? That's what we're doing. We're slowly undoing it. The original had squared, right? What's the opposite of squared? So does our answer have a square root? Then it has a minus 4. What's the opposite of minus 4? Does our answer have a plus 4? There you go. Okay, so we're just slowly doing the opposite until we're done. Look at this guy. This guy's got a root. It's kind of like a square root, but it's 7th root. Okay? So first step, change it to y. Then switch x and y. It's a little buried. Y is a little buried in there. So how am I going to get y out? Well, you're going to do the opposite, just like we've been doing. So I have two things. I have a root 7 and a divided by 3. I can't do anything with the inside until I get rid of this root. So what's the opposite of 7th root? So if the opposite of squaring is square root, what's the opposite of 7th root? 7 power, right? 7 power. Okay? So what I'm going to do is I'm going to give this guy a 7 power, and I'm going to give this guy a 7 power, because whatever I do to one side, I got to do to the other. So a 7 root and a 7 power cancel each other out. So now I don't need the parentheses because all I have left is y divided by 3. Divided by 3, what's the opposite of divided by 3? Multiply by 3. Multiply both sides by 3. Give it its inverse tag. Done. The original had a 7 root and division by 3. Our answer has a 7 power and a multiplied by 3. Those are the opposites. Okay. All right. Okay. We're going to do one more, and then I'm going to give you one more to do on page 32, and then we'll be done for today. All right. Letter D. Switch. Switch. Okay. Step 1 and 2 done. Step 3, solve for y. So y, again, is stuck in there. So I have to slowly unwrap it. Y is in here. What's the first thing? So I have a minus 10, a 5th power, and a divided by 3. Or sorry, divided by 9. Sorry, divided by 9. So the first one is, yeah, get rid of the fraction. Multiply by 9. Okay, I can't add 10 yet because it's got a power. So what's the opposite of 5th power? Yeah, 5 root, 5th root, yeah. 5th root, a root with a 5 on it. So do that to both sides. Y minus 10 equals 9x, the 5th root of 9x. Close. Almost y, so how do I get y by itself? What's the last step? Add 10. Add 10 on the outside of the root. So the inverse is equal to the 5th root of 9x plus 10 on the outside. That's it. Doesn't matter what they give you, just do the opposite. Just keep doing the opposites, keep doing the opposites, keep doing the opposites. Your final answer should have the opposite of whatever you started with. I had a 5th power. What's the opposite of 5th power? 5th root. I had a divided by 9. What's the opposite of divided by 9? Multiply by 9, 9x. And then I had a minus 10. The opposite of minus 10? Add 10. Okay? All right, so I'm going to give you one more to do on page 32, and then we'll be done for today. Okay? Mm-hmm. Yeah, do you have your... Yes, leave it right there. Okay, last one. Page 32. Find the inverse. Okay, first step, replace f of x with y. Check. Second step, switch x and y. Everything stays in the same spot. You see how 1/2 and plus 6 stay in the same spot? They don't change. Just x and y change spots. Next step, solve for y. Okay, so now I need to get y by itself. Okay. So like I just said, when we're solving, we start at the bottom of PEMDAS with the addition subtraction. So that means that plus 6, that's where we start. Minus 6. So I get x, take away 6 equals 1/2 times y, because it's times y. Numbers and letters in math stuck together, that means multiplication. Okay, so now, done with the addition subtraction, now I have multiplication. How do I get rid of 1/2? How do I split up 1/2 and y? Usually I divide, right? You do that if it's a whole number, but this is a fraction. So instead of dividing by a fraction, what's the other way to do it? It involves multiplication. What number could I multiply 1/2 by that would be the same as dividing by 2? Not multiplying by 2. So think of this. If I said, there's 30 of you guys in the class, I'm going to divide you up into 2 groups. How many people would be in the same group? Or how many people would be in each group? 15, right? So instead of saying divide by 2, could I say, okay, so what I'm going to do is I'm going to take half the class, put them over here. I'm going to take half the class and put them over there. Is that the same thing? So instead of saying taking half, I'm going to say I'm going to use 2. Just have to use different operations. So instead of dividing by 1/2, I'm going to multiply by what's called the reciprocal. What's the reciprocal of 1/2? Yeah, just flipped. 2/1. So instead of dividing by a fraction, multiply by the reciprocal. Flip. Because look it. 2 times 1 makes 2. 2 times 1 makes 2. What's 2 divided by 2? 1. That's what I wanted. I wanted to make a 1y. You just got to remember, this guy's a binomial, so I got to multiply by both. So I have 2x minus 6. And just do distributive property, you get 2x minus 12. Okay, let's flip it around. 2x minus 12. Done. So instead of dividing by fractions, multiply by the reciprocal. Okay, that'll help you out. Okay. Yeah, do you have your